Hello friends, welcome to my YouTube channel. This is Namakanda the Scientist. So with me I have a question which says that find the direction cosine of the following vector and hence find the angles alpha, beta and gamma that the vector r makes to the positive x, y and z axis. While we have that our vector r is equal to the square root of 2I plus j, then we say minus k, like that. Okay, so we can rewrite our vector r the way it is for now. So we write it the way it is. Now this simply gives us three components, the x, y and z, while we have that the x component for this particular vector is equal to the root of 2. The y component is simply equal to a positive 1, since that's the coefficient multiplying with j, and the z component is equal to negative k. So our question is simply telling us to find the direction vector. So this question is made up of two parts. The first part is to find the direction cosine, and the second one is to find the angles, which are alpha, beta and gamma. So now let us first find the magnitude of our vector r. So the magnitude will just be the square root of, we'll get the components, we square them. So say the square root of the component of x squared plus the component of y squared, then plus the component of z squared. So this will simply give us our answer to be square root of 2 plus 1 plus another one, so which will give us square root of 4, giving us a 2 as our magnitude for our vector. Now let us simply find our direction cosines. So we have for alpha, beta and gamma. So we have cos alpha, which gives us the direction cosine. So this is the component for x over the magnitude for our vector r. So that is our formula over the magnitude for our vector r. Okay, so this, and also mean that our angle come out as cos inverse of whatever we have there on our right hand side for the direction cosine, like that. So now let us find our cos alpha, which is the direction cosine. So rx, which is the component of x, is simply equal to the square root of 2 over the magnitude, which is a 2. So this is our direction cosine. Now with this we now find the angle theta, alpha, which is equals to cos inverse of what we have, which is square root of 2 over 2. Now we end up having our alpha, which is equals to 45. So the angle that alpha makes to the x-axis is simply 45, meaning the vector, which is the 45. Then we now come and find the one for beta. So this will be the y component over the magnitude of our vector. So this will be equal to, the y component is simply giving us a positive 1. So say a 1. So we have a 1 there. Then we divide it with the magnitude of our vector, which is a 2. So that is our direction cosine. Then we now find the angle. So beta equals to cos inverse or arc cos of what we have there, which is half. Then this simply gives us a 60 degrees for our beta, the angle that the vector makes to the y-axis. Now we come and find the direction cosine for gamma, or for the z-axis. So that is gamma, it will be equal to the z component divided by the magnitude of our vector. So this gives us, there we have a negative 1 as our z component. So we get a negative 1. Then we divide with the 2. So this is our direction cosine. Now we find the angle from the vector to the z-axis, which is like that. Then this simply gives us our beta to be equal to 120 degrees.